Dear learners, welcome to the course MSD012 Ecosystem and Natural Resources. Today, after having few sessions related to energy, about the concept of energy and then non-renewable energy and alternative source of energy. Today, the point is that when we are having alternative source of energy, looking into the issues we are facing because of that depletion of stock resources, energy resources. The most important is how to store the energy. So let us have a quick look into the basic approach what we can follow in storing this energy. As a student of sustainability science, we need to understand those concepts, what is happening around the world, right? As we know that the major obstacle to the widespread use of many alternative energy sources is one of the problem of unevenness in terms of time, space, frequency, intensity, or availability, magnitudes of availability. So how can we have to solve such kind of problem? To a great extent, so it can be solved by using efficient energy storage system. One of the reasons that we know that the fossil fuels in general and oil in particular, it can to dominate the world energy because of their high energy content and ease of storage and transportation. At the same time, we know that hydrogen gas also offers some of the advantages, but if you look into disadvantages, we can say, I must say this as a limitation of hydrogen gas. It is being bulky and lightweight. It is much more difficult to store. And we know that electricity is one of the most versatile energy sources, and but it is difficult to store in large quantity because most of its use is immediately after production. That's why the question comes into how to store the energy, because when we talk about sustainability, and the most important is availability, accessibility, affordability. So in that, to meet all those things, when we look into energy sources or energy resources, that talks about how to store it, right, in terms of long-term use or short-term use, depending upon the situation. So we can look into two major storages. What is one is electrical energy storage, another is heat energy storage. When we talk about electrical energy storage, we know that surplus or intermittent electricity, maybe from non-renewable or maybe from alternative sources in a mass scale, that can be stored. And some of the storage, the technique, or what we can say way of storing electrical energy is, one is we can use pumped hydroelectric storage, and we can use compressed air energy storage. And when you talk about pumped hydroelectric storage system, in that it pumps water to a reservoir at high elevation when demand is low as in night, to use it for electricity generation when the demand is very high, right? So however, if you look into the net energy yield, they are negative, and the reported efficiency are in 70 to 75% of range. So it is, again, we can say it is also associated with capacity limitation and other environment aspect, is in the case of when we know that the impact of having big dams. Then another way of storing electrical energy storage is, we know that is compressed air energy storage. Here in this system, they use an underground pump electric system which stores air instead of water, and it can be used later on for generating electricity using a modified gas turbine as per the requirement from time to time. Example of such kind of system are, when we talk about underground caverns, especially in salt domes, then we use abandoned mines, then abandoned natural gas wells, and it's particularly it is very common in empty aquifers. Then the net energy yield in such kind of storage is moderate to high. However, the system is we can say that when we talk about sustainability, we are looking for a pollution-free or eco-friendly. But if you look on from that perspective, this kind of system what we talk about is not neither completely pollution-free. The another form of electrical energy storage is electrochemical energy conversion. This electrochemical energy conversion was developed by Alessandro Volta around 18,000 AD. That is very commonly used. That is the system of batteries, right? When we look into those common battery system, they are of lead acid variety, and utilize lead plates and dilute sulfuric acid. So various types of miniature batteries and dry shells were commonly used, and they are of nickel cadmium batteries, lithium metal hydride batteries. These are some example of this category. So if you look into the energy density, means energy storage per unit weight, and number of surge that discharge cycles, it takes about normally 500 to 2000 in. And these two, that energy density and the discharge cycle, number of surge discharge cycles, they are deciding factor of the quality of that batteries. And nowadays we have seen a number of batteries which they use different kind of metals, non-metals, like we have zinc chlorine, zinc bromine, and hydrogen nickel oxide. And because if you look into their efficiency and use of easy use, they are lighter and long lasting. So this is how we are using batteries for storing the electricity. Another promising line which are very, particularly today's in the front of research in this line is involving high temperature batteries, that is 3000 up to 300 degrees centigrade. That is actually basically such kind of high temperature batteries, they are mostly suitable for stationary purpose. And we also know about one form of energy storage is fuel cells. If you look into those fuel cells, we'll see that the pollution caused by such batteries that automobile that we search automobile from such kind of fuel cells, they are non-renewable energy sources, and then if you compare those things from non-renewable sources, they are leisure, less pollution, and they are we can say that is very better than other source of other storage system. Another way of storing this electrical energy is using flywheel, simple flywheel. In that, what happened in this simple flywheel method? The spinning is in mounted case, like in a vacuum at a rate of up to 200,000 RPM, and there stores kinetic energy that can be used whenever it's needed. Another technique is superconducting magnetic energy storage system. So in that, extra current is allowed to circulate around a closed superconducting loop of nearly zero resistance and can be useful later on. But beside this is this kind of superconducting magnetic energy storage, which are expensive, it also requires very large areas of land and associated with other potential environmental health problems. Especially when you have that superconducting magnetic energy storage, they have electromagnetic fields and created. So this is some of the limitation of different kind of energy storage, electrical energy storage system. And coming to the heat energy storage, we know that the passive heating system, which we discuss when we discuss about that renewable source of energy from sunlight and so on. We know that this passive heating system are the major heat storage techniques, and when the heat is stored in a material by increasing its temperature without any change in its state, that is called sensible heat storage. The material used in this storage system are, that we can use rock, clay, water, oil, salt water, etc. On the other hand, now we use another system called latent heat storage system. In this system, when the energy is stored as a latent heat of liquid or gas due to change in phase of the material, kind of storage that is we call is latent heat storage. In this latent heat storage, we use the material which regains its original state on release of the excess heat. So the conversion of water or ice to liquid and back to solid, conversion of water to steam and back to water, these are the examples of latent and heat storage. The another heat storage system is thermochemical heat storage. This thermochemical heat storage, they uses reversible chemical reaction to store heat energy. For instance, methane and that steam means water vapor, water steam, they form that syngas. So this syngas in the presence of catalyst again forms water vapor and methane by releasing the heat. So other pairs of such kind of methane and steam, in this case syngas, others are reactant product like ammonia nitrogen and hydrogen, calcium oxide and water calcium hydroxide. So these are the materials that used in thermochemical heat storage, right? Then when we look into, we know that energy crisis is happening, demand of energy is increasing because of different pressure, because of different region, we know that. So how we have, whether there is any alternative energy that sources can be stored or not, right? So if we look into those future alternative energy sources, we can look into solar hydrogen revolution, what is happening nowadays. We are looking towards that direction, that when we talk about this solar hydrogen revolution, that proposes hydrolysis of water using solar energy to produce hydrogen gas, and it is one of the future alternative to meet the energy demand. In extreme case, with a moderate life cycle and have less environmental impact. On the other hand, hydrogen can be produced using electricity from the hydropower, solar thermal, solar cell, biomass power plants and wind farm. So in the initial phase, hydrogen means the mixture of methane and around 15% hydrogen. That means hydrogen can also be used. Other future alternative energy sources or storage of energy can be fuel cells. Fuel cell is a very innovative where it has energy conversion efficiency is high, about as high as 65%, and which can be minimize the environmental impact, even the consumption of the clean fuel if we use the clean fuels. So if you look into that fuel cell as an alternative energy sources, the mechanism what we see in the fuel cell is it is an electrochemical cell that generates electricity through reaction between a fuel and oxidant and triggers in the presence of an electrolyte. Another, future alternative energy sources is microbial fuel cells, which uses microbial metabolism in generating electricity. So fuel cells can operate continuously as long as necessary reactant and oxidant flows are maintained. Unlike other that conventional electrochemical cell batteries, what we're talking about, that they have thermodynamically those that electrochemical cell batteries are closed system, and these fuel cells are thermodynamically open system because they consume reactant from an external sources and that can be replenished. So we have another that system. We have also that hydrogen fuel cells. That is also one of the future alternative energy sources for the future. In this hydrogen fuel cell, it uses hydrogen as its fuel and oxygen acid oxidant. That oxygen is usually get from the air penetrating. Many more fuel cells are available nowadays, like hydrocarbons and alcohols with chlorine and dioxide and as oxidant. So these can be such kind of hydrogen fuel cells and such kind of fuel cell system. Methane clathrates in the ocean, especially in the ocean bed, and they are the source of methane. And this methane clathrate is continuously forming, means continuous formation is happening. And this methane clathrate, as we also known as methane hydrate, hydromethane, or methane ice, or fire ice, it's a solid where a large amount of methane remains trapped within a crystal structure of water similar to ice. So 1 liter of methane clathrate solid can release 168 liters of methane gas on average. So magnesium energy cycle bioalcohol from lignocellulosic material using that critical technology, and bio oil from biomass, they are some of the promising areas like methane clathrate, promising areas of energy sources. We also know that nuclear fusion of smaller radionuclide that to form an element of bigger nuclei, hydrogen to helium, and that they also can be produced, they produce energy even at higher than nuclear fusion. These are also possible future source of energy. So if you look all those this alternative future source of energy, they remain relatively pollution free as compared to others. So today in this small session, what we discuss is about how to store the resources, energy resources for long-term uses, and what are the future possible energy resources. These are few of the references. Thank you. See you in the next session.